All right, so here again, we're supposed to determine the domain and the range of the function. So domain and range. Well, domain are x's. So if we look here, the leftmost x is going to be right here, and that's going to be at what? That's going to be at a -5. It's a closed circle, so it's going to include it. So we're going to have -5 up to. Now we look and it keeps going and going and going all the way up here to 6, and it includes 6, so that'll be a closed bracket as well. Now our y's, what's our lowest y? Well, that looks to be a -1, and it includes that. So -1 up to the tallest one, which looks to be a 3, and it includes it as well. And so that would be our domain and our range for this function. All right, so here we're supposed to determine whether f of x represents a polynomial function, and basically, if possible, we need to identify the degree and type of polynomial function. So as long as it's a polynomial, then we find the degree and type. Well, if we rewrite this as 9x squared minus 8x and then a plus 4, we see that this is a quadratic function. So it's a quadratic because we have that power of 2, and it is a polynomial. So yes, so we can say yes, and then we can say it's a quadratic, and then the last thing is the degree. Well, since the degree is the highest power, it's a 2, and 2 also gives it the form of the quadratic. So it's a polynomial function that's a quadratic, and it has a degree 2. All right. What about the next one? Uh, all right, so here we're supposed to determine whether f of x represents a polynomial function again, and then if possible, identify the degree and the type. Well, here our x to the fifth is in the denominator. Well, because that's in the denominator, that's not going to be a polynomial because we can't take it to the numerator, the 2 to the numerator all at the same time. And so then this one is not a polynomial. And as such, we don't have to worry about the degree and all that stuff or what type it is. All right, so here we're supposed to evaluate if possible given these values of x. So basically, we're just going to figure out what is f of 4 and f of a -7. All right, well, if I plug in 4 here, that's going to be absolute value of 4 plus 1, which gives the absolute value of 5, which is just going to be what is the positive of that, which is 5. Now here, if we plug a -7 in, plus 1, -7 plus 1 is -6. When we take the absolute value of that, we need the positive of it, which is giving us a +6. So that's the function absolute value of x plus 1 evaluated at x equals 4 and x equals 7. All right, let's stop there and we'll come back for some more.